Hi everyone, so welcome back to our channel that is Generative Mind AI, and this is going to be the third video of NLP using a transformer. So in the last video we have just seen about all the basics of the natural language processing where we have the NLP have arise, and also in the previous video we saw about the word to vex. Again this word to vex and this all thing will just deal in the coding part as well. That was all the theoretical part, so we are just moving all the theoretical part. Soon we are going to jump into the coding section. So once we are just really complete with all the theory of the natural language processing transformer, all the models, stop words and these all things, then we are going to jump with the coding part. Clear? So this is going to be the first deep learning neural network we are going to start in NLP, and that we call as a recurrent neural network. And this is going to be the one of the most important neural network because it has been started from where the scientists or researchers they started thinking how we can just use with the play with the text of data or any sequence kind of data, whether it is a time series data or whether it is whatever you are speaking or writing something text. Because whatever you are speaking or whatever there is something time series data, that depends upon the previous one, like previous whatever you have spoke. Like if I'm just saying I like a boy, or I the boy is playing a football, so that every words will have some you are just saying in certain time stamp. You can't predict the last word, and then after you are just saying boys play like something, so it might be not understandable. Okay, so basically why we are using recurrent neural network, if you went through the computer vision, you will just analyze that we don't have any dependency while training your models. If you have multiple of the images, every images is independent of their whatever you are just training the previous images. In the images you will have something like cat and dog classification you are doing. You might have something, you can say you will have cat in some images, you will have dog in some images, but their position is not going to be fixed. So it does not even matter at all whether whichever the position you are going to have your cat and dog, because in the last model is trying to just capture the features of the cat and dog. Okay, that's what the computer vision is. But in the natural language processing, all the sequence kind of data, you need to have the previous words to predict the next word. Or if you're just going with the stock market or any time series data, you need to have previous all the details, then after you are going to predict something in the future. That where the recurrent neural network arises, and this is going to be the one of the first deep learning neural network that has been published. Again, it has been published way in 1990, and from there we don't have again we don't have any resource to implement this thing. But nowadays, even we are moving further and further, we have moved towards the from RNN lstm, we started with the transformer. But again, we should know each and everything basics. And even nowadays for the predicting for real time, because the network complexity is less as compared to the whatever we are using nowadays. So we'll just focus on the RNN. So RNN, recurrent neural network, are the type of neural network especially designed for the dealing with the sequence of the data. So whenever you have any sequence data, whether it is a time series data or whether whatever you are speaking, the text data, that sequence matter. In that case, you can just go with the recurrent neural network. Okay. Unlike traditional neural network, and RNN have a memory element that allow them to remember information from the previous step in the sequence. I will just show this thing in again in the diagram. I will just walk through all that, whatever the layer we have, the input layer, and then after you will have the hidden state, and then after you will have output state. And I will just go through each and every layers in the much detail. So why we need RNN in for this situation? Like think in the situation where the order of the information matter, like in a sentence or in time series data, which already I've explained you. So RNN are the great for this scenario because they are considered for the context of the each price of the information based on the chem before. Clear? Because whenever you are just dealing with the time series data, or whenever you are dealing with any sequence kind of data, in that case you can just go with the RNN. Clear? Now we'll just go with the working of the recurrent neural network. That is basically this. I will explain you. This is the block diagram. I will just go walk through this block diagram. Then after I will explain you what is unfold, and then finally I will just give you the equation of any one of the layers, so it might be understand to you. Okay. So first start with the input at each time step. So first of all, just see this diagram and you will able to understand. Because this is the unfold. It is like you have the input units, and you will have a hidden units, and you will have output units. This hidden unit is basically a RNN, where you are going to apply the RNN, recurrent neural network. Clear? The first step is basically what you are just going to see, the time one input units. Because see, whenever you are just feeding any words, like sequence of the word, you will fit at every timestamp. So this is going to be the first timestamp, this is going to be the second timestamp, this is going to be third timestamp. I'm just going to say any three words like mm, how are you, I'm just saying, then how you will just put in first timestamp, or you will just put in the second timestamp, and you are going to put in third timestamp. Why? I will just explain you now. See, the first timestamp, you don't have any previous before how it is, there's no such any kind of words. The first timestamp you are just putting is how, and this is going to be the hidden units. Okay, I will explain you again the formula. This is going to be the first what you are just putting, the this is the input at this timestamp. So you need to put whatever the how are you are going to put in the first timestamp, second timestamp, and third timestamp. Based on how many words you will have, that number of timestamp you need to put. Again, whenever you are putting the second timestamp is whenever this operation is happened, then after you are putting that second timestamp, like r you are just putting, whenever you are just putting r, means whatever the previous word it has, because this hidden unit you are keeping this one as an input to this hidden state, and as well as this also input, means you are making this time to remember that the previous one is how, and the current you are just putting as r. Okay, so this is what you have the long term dependency, that what RNN is able to see. What's long term basically means that it is capturing the previous word, whatever the previous word it has, it is going to capture, and the current word it is going to capture, and then finally it is going to give you some output. Okay, and again, and third is basically r, and then after you are fitting whatever the previous timestamp he has, it has the all the details of how r, and then third timestamp you are just putting as u. Clear? I will explain you again this one as in the formula, it is going to be really understandable. So I think you will understand this one. Input at each timestamp, this is this first point, I hope so it is clear. Like at each timestamp t, the RNN receive the input as xt basically means every timestamp, and this input could be words in any sentence, a value in the time series, etc. So whenever you have any sequence kind of data, whether it is any sentence or whether it is any time series data, you need to just provide each word at every timestamp. I hope so this is going to be really clear. Second thing is the hidden state. The network maintain a hidden state, that is st, where it acts as a memory. Because whenever see, whenever I was explaining that hidden state 2, this hidden state 2 is going to receive one more input from the previous one, that is basically how information it is receiving from the previous one, and the current input is going to give you the r. So that's why it containing all the previous one. And if you are going to see about timestamp 3, it is receiving how are both, and then after you are just putting, because how are you, these three sentence I'm just giving for example, you can have n number of words, sorry, three words I'm just giving you the example. And then after recurrent connection is basically the key features of the recurrent connection is a loop that allow information from the previous timestamp to influence the current hidden state, and the connection enables the network to maintain the context over the sequence. Basically you have this one as a recurrent basically means it will have the same kind of network you are going to use for every timestamp. Clear? And then after you are going to update the hidden state, the hidden state is st is updated based on the current input xt and previous hidden state st minus 1. Basically every timestamp you're just putting, this hidden state is going to be updated. Like for hidden state 1, it does not have anything, it is going to be a blank. Hidden state 2 will have the information from hidden state 1, that is has given input, that is how. If I'm just again taking how are you, then how, and then after whatever the input you are going to give, and then after finally you will have the information. So now I will just go through all the okay, we can just go with the output at each timestamp. Then the output yt is generated based on the current hidden state st, and the output can be for a task like predicting a next words or value or whatever you have, like classification sentiment in a sentence. Now we can just go with the formula, and how you are going to understand really easily. Whenever we are just saying unfold basically means that x and y is going to be changed, but this is going to be every time same. Like RNN you are just going to modify, but all the like hidden state is going to be updated after every timestamp. See, xt minus 1 is basically your the previous timestamp. I'm just saying xt is your current timestamp, xt minus 1 is your the previous timestamp, and xt plus 1 is your next timestamp. Okay, so basically what we will just do, xt basically it is you are going to give one input, and from xt minus 1 it already have an input. Again I am just taking example of how are you. So now how you are going to put, already you have put in xt minus 1 timestamp, it is going to receive st minus 1 is basically the hidden state information of this timestamp. Okay, and whenever you will see wx of h is basically the weights of this input, and then after you are going to receive from this now again the second timestamp, that is a current timestamp, you are going to give a input like xt, that is r you are going to give, and r is going to, r whenever you are going to give, it has the weight of w of xh, and then after you will receive xt minus 1, and you will receive this information. Now you are going to multiply, like dot product you are going to give, like it has already formula of f of x is f of x, and then after you will have to give ht comma ht minus 1, uh, xt comma st minus 1. I'll just explain you in this, you will easily understand. So I don't go for now as a formula, you need to just understand how it works. Okay, after every time stem for now, and you will get an output is basically whatever is going to be your next word, like whenever you are just putting how. Okay, after how you the model must predict something like r, so I yt minus 1 is basically your the r. Okay, and then after again you are just putting r as an input, and outputs will be u, how are you. Okay, so this is how the next word is going to be predict. Basically it learns whatever the previous word is said, and based on that previous word it is going to be predict. Now we'll see a one formula, and it's going to be really simple. I don't want to go in much complex for now. What I will just go with the current this block diagram, that is RNN of the current timestamp. Clear? So st, whenever you are going to see st is basically, you can just say about st only, st or st, it makes you, it's like a syntax whichever you are just going to change. So st minus 2 is basically the previous to previous timestamp, st minus 1 is your previous timestamp, st is your the current timestamp, and st plus 1 is your the next timestamp. So you want to just see what's the output equation you are going to get for this current timestamp. So current timestamp is basically w1. W1 is basically the weight, whatever I just said, you have the weight for this one, you will have the weight for hidden state, you will have the weight for the output state. Basically whenever during the back propagation through time, the weight is going to be updated. Clear? So this is basically whenever it is basically you're the input, whatever the input you are going to give, st minus 1 is basically you're the previous timestamp, this you are going to take, then after you what is the weight, w1 is basically what the weights. Okay, so you are going to multiply w1 into lt plus w1 into st minus 1. Basically means that you want to just see your current timestamp data, that is it, whatever you are getting, that is your current timestamp, and the previous timestamp is basically st minus 1, and plus you have some biasness in that network. Clear? So st is basically your multiplication of this weight into it plus multiplication of weight into st minus 1, that is going to be your the hidden state. St is basically your current hidden state for equation you will get. Clear? And ot is basically your the output state, whatever you have. Again w2 is basically your the weight of that specific whatever the output you have into hit this hidden state, and hidden state equation what you got from st, that is w1 into it st minus 1 plus biasness. Okay, and you will have, again you will have some biasness for this also. So this is how we are just getting again, and it is going to be really simple. You don't have to go much in the complex. In the summary I can explain you. You have a hidden state, you have input state, you have hidden state, you have output state, you will have something weightage for the input state, you will have weightage for the hidden state, you will have weightage for the output state. And this is hidden state is basically which you can just say you, it's like a memory, it is remembering whatever the previous one you have all the equation, and then after whatever the next word is going to be predicted based on the equation, it is going to be calculated. Clear? So again, this was all about the RNN, but there is really challenging in whenever you are dealing with the RNN, whenever you are just using RNN for the real world or real time data. So the one most challenging is that RNN have their challenge. One common issue you will get a vanishing gradient problem, and you know vanishing gradient problem occurs basically whenever you have gradient during the back propagation, because this all whichever we are just talking about, that was all forward propagation. But whenever you are updating the weight, I hope so you know about whenever you are just updating the weights like gradient descent you are just doing, So in that gradient descent, what you are applying any stochastic gradient descent or whichever the type of Adam gradient descent, you are updating the weights of that network. You are just updating the weights of every layers, like whichever I was just talking about, W1, W2. This is the weight, and it give the priority which word is going to be have most important, which word is going to be have the predicting to the next word and previous word. So this updated you are just going to throw in the during the back propagation through time. So in the RNA you will do back propagation through time. And one of the most important issue is basically vanishing gradient problem, and it is commonly question it is going to be asked in nowadays. So what the issue with the vanishing gradient problem? You have vanishing gradient problem. With the help of vanishing gradient problem, you whenever you are just applying something like activation function, and activation function is like sigmoid activation function or any 10h activation function, they have certain range, like -1 to 1 has 10h activation function, or sigmoid has 0 to 1. So whenever you will do the sigmoid derivative, you will get a again 0 to 0.25, and again the gradient is really small, because during the back propagation you are updating the weight. Vanishing basically means your gradient is vanishing. Okay, means whenever you are just updating the weight, there is no change in the weightage of the layers after 7, 8, 10 layer and number of layers. And in that case, whenever there is no change in the layers, the weightage of the layers, means you are just your network has been vanishing. The network is not learning new things. Whatever the previous it has learned, it is going to be the same. So that is what vanishing gradient problem. Again, whenever to improve this vanishing gradient problem, to tackle some of this challenging, what we are just going to use, we are going to discuss this thing in the next video, that we call as a long short term memory, LSTM network. Again, that is again it is not going to be the best, but again it is just clear whatever the vanishing gradient problem was occurring in the RNN. So these architecture have improved memory capabilities, making them more effective of the learning from longer sequence. Because whenever you have long term dependency, you will occur a vanishing gradient problem in the RNN. It is good for whenever you have shorter sentence, like I'm just talking random, like 20 words before or 30 words before, it might able to understand. But whenever you are going to go with the 1000 word before, or something like 500 word before, at that time RNN equation is really complex, and at that situation, whatever the activation function you are using, like sigmoid and basically you can just say about the 10h activation function, their gradient is going to be really small. And whenever you are multiplying with the small to small, and suddenly you are going to come with equation of like something like 0.0001, that is approx equal to 0. So there is no change in the weights. At that case, the vanishing gradient problem occurs, and it is going to be one of the most important things even asked in everywhere in nowadays in interviews. Okay, so now in the next video we'll just come with the long short term memory, and I will explain you in much detail how we are overcoming from the vanishing gradient problem and what we are using for that. So I hope so you understand, and see you in the next video. Just like my channel, subscribe my channel. Thank you.